Okay, so this is going to be our auditory study guide for PowerPoint lecture number 2, which was all about hematopoiesis and erythropoiesis for hematology. This will be on exam 1. What is hematopoiesis? The process that replaces circulating blood cells. Bonus, it depends on precursor cells that can divide, regulated by cytokines, and it occurs in a specialized microenvironment. What is differentiation? It's a process generating diverse cell types from initially similar cells. In differentiation, cells acquire different properties. What is commitment in cell development? It is when two cells from the same precursor take different developmental routes. What is maturation? It's the entire process from commitment to full development of a cell's characteristics. What is a stem cell? It's a cell that can self-renew and give rise to a specific lineage. Bonus information, adult stem cells produce specific tissues. Embryonic or pluripotent stem cells can produce all cell types. What are hematopoietic stem cells, or HSCs? They are adult stem cells that give rise to all blood cells. And what is the identifying marker or cluster of differentiation marker for hematic stem cells? CD34. What percentage of bone marrow cells are hematic stem cells? Hematopoietic stem cells. It's approximately 0.5% of bone marrow cells. Where do hematopoietic stem cells reside? They are in the red bone marrow of the long and irregular bones, so ribs, sternum, ends of long bones, pelvis, vertebrae. Bonus, yellow marrow stores fat, and they're not active in blood production inside the bones. What are the 3 possible fates of hematopoietic stem cells? Self-renewal, differentiation, and within that CLP or CMP, and or apoptosis. What is self-renewal? Hematopoietic stem cells make copies of themselves to maintain the stem cell pool. Extra bonus information, approximately 8% divide daily, and that can actually increase if necessary in the body. That might be if you've had a lot of blood loss and need more blood in your body. What is apoptosis in hematopoietic stem cells? It is programmed cell death to regulate stem cell numbers. What are progenitor cells? Progenitor cells are cells derived from HSCs that are committed to a specific blood cell type. So, bonus information, 3% of marrow cells cannot self-renew and have recognizable lineage features. How are progenitor cells identified? By immunophenotyping or colony formation in vitro, and that's the CFU or BFU. Colony forming units or burst forming units. Okay, so what are CFU GEMM's precursors for? And the key here is GEMM. Granulocytes, erythroid, monocytes, and megakaryocytes. What are the CFU GM precursors for? And again, the key here is the GM. Granulocytes and monocytes. And what are the CFU MK precursors for? And that's capital M, lowercase k. So we're only talking about one thing here. Megakaryocytes. What are maturing cells? They're progenitor cells showing morphology of their lineage. 95% of marrow hematopoietic cells committed to a population. What drives hematopoiesis? Cytokines or hematopoietic growth factors, little h GFs. What do hematic growth factors do? And I'm looking for 4 different activities here. They stimulate proliferation, differentiation, trafficking, and survival of blood cells. Who produces hematopoietic growth factors, HGFs? And I'm looking for 1, 2, 3, 4, 5, 6, 7 answers here. It's quite a bit. So the hematopoietic growth factors are produced by monocytes, macrophages, activated T cells, fibroblasts, endothelial cells, osteoblasts, and adipocytes. The exceptions are EPO and TPO. How do cytokines signal? There's 3 different steps I'm looking for here. So cytokines signal by binding to receptors, which triggers intracellular pathways, which modulate gene expression or act rapidly without gene regulation. What is stem cell factor, SCF? Cytokines supporting proliferation, so SCF is a cytokine, differentiation, and survival of the CD34 positive stem and progenitor cells. What are colony stimulating factors? So this is CSFs, colony stimulating factors. They are growth factors stimulating specific blood cell types. So like GCSF, they support granulocytes. MCSF support monocytes. Colony stimulating factor. What are interleukins, so ILs? Interleukins are cytokines that support hematopoiesis and immune function. What is thrombopoietin, TPO? TPO stimulates platelet production by acting on megakaryocytes. Where is TPO produced? In the liver. What is erythropoietin, EPO? EPO stimulates red blood cell production by acting on erythroid progenitors. What is production of EPO triggered by? Low oxygen or hypoxia. Where is EPO produced until birth, and then where is it produced after? It's two different locations. EPO is produced in the liver until birth and then in the kidney. EPO is produced in the kidney as an adult. What are the three phases of hematopoiesis? Mesoblastic, hepatic, and medullary. What is the mesoblastic phase? So I'm asking, when does it start? Where is it located? And when does it end? The mesoblastic phase is embryonic hematopoiesis, starting day 19 after conception in the yolk sac and AGM, and it ends 6 to 8 weeks after gestation. What is the hepatic phase? So where does the hepatic phase take place? When does it take place? Okay. So the liver becomes primary hematopoiesis site approximately week 5 through the 3rd month. So we go from mesoblastic in the yolk sac and AGM until about 6 weeks gestation, and then we go to hepatic in the liver primary at the 5th week to 3rd month. But the spleen, kidney, thymus minor, red blood cell produced until birth. What is the medullary phase? Red marrow becomes site of 6th gestational month. Clavicle first bone to produce blood cells. Where does hematopoiesis occur in adults? Flat and irregular bones and proximal ends of long bones. So the flat and irregular bones are the ribs, sternum, vertebrae, skull, and pelvis. What is the composition of bone marrow? I'm looking for 2 different compartments. Vascular compartment and endosteal compartment. What are niches in hematopoietic marrow? Microenvironments where erythroblasts, granulocytes, megakaryocytes, and lymphocytes develop. What is stroma? Support tissue producing cytokines, and that includes macrophages, fibroblasts, adipocytes, and endothelial cells. Let's see how much more we have. All right, we're not too much more to go. What is blood cell egress? It's the process of mature cells leaving marrow via venous sinuses regulated by cytokines. What is extramedullary hematopoiesis? Blood cell production outside bone marrow, like thymus, spleen, and lymph nodes. What is the thymus? Bilobed organ under sternum. The cortex equals immature T cells. Medulla equals mature T cells. And it trains T lymphocytes through positive and negative selection. What are the spleen's major functions? I'm looking for 3 answers here. They recycle old or damaged red blood cells, store platelets, red blood cells, white blood cells, and they aid in the immune response. What is the difference between white and red pulp? White pulp includes T and B cells, acquired immunity. Red pulp has the red blood cells, platelets, and phagocytes. What is culling in the spleen? Culling is removal of old or damaged red blood cells in a harsh environment. What is pitting in the spleen? It's removal of particles from red blood cells without destroying them. What does the lymphatic system do? It returns extracellular fluid to circulation, filters lymph via lymph nodes. How many red blood cells are in blood? There are 4 to 5 million per microliter, which is approximately 20,000 to 25,000 billion total in adults. And we already know this, but red blood cells are alive in your body for about 120 days before they get recycled out. This is a really long one. What are the stages of red blood cell maturation? So we go from HSC, myeloid progenitor, MEP, BFUE, CFUE, and so this is where we can start seeing visible features in the microscope. Pronormoblast, basophilic normoblast, polychromatic normoblast, orthochromic normoblast, reticulocyte, and mature red blood cell. What is a pronormoblast? It's the earliest nucleated red blood cell precursor. How big is a pronormoblast? 12 to 20 micrometers. What is, how big is a basophilic normoblast? So this is the next one after pronormoblast. Basophilic normoblast. It's 12 to 17 micrometers. So notice it's starting to get smaller. The nucleus to cytoplasm ratio starts to get smaller. No nucleoli. How big is a polychromatic normoblast? So polychromatic comes after basophilic. It is 11 to 15 micrometers. And this is, when is the last mitotic stage of a maturing red blood cell? The polychromatic normoblast. What is an orthochromic normoblast? Or how big is it? So it's 8 to 12 micrometers. Notice we've gotten smaller. The nucleus is condensed. The cytoplasm starts to become a reddish pink. So it can no longer undergo mitosis at this point because the nucleus is so condensed. It's got the heterochromatin, which is no longer transcriptionally active. What is a reticulocyte? So the nucleus has been extruded. It's 7 to 10 micrometers, pale blue cytoplasm. Okay, this is a good question. So how much of the hemoglobin is made in the normal blast stage so all the stages before reticulocyte, versus how much hemoglobin is made in the reticulocyte stage? So I'm looking for percentages here. 80% of hemoglobin is made in normal blast stages and 20% in the reticulocyte. So again, the normal blast stages are pronormoblast, basophilic normoblast, polychromatic normoblast, and orthochromic normoblast. Last question. So what are some of the descriptions of a mature erythrocyte? So I'm looking for size, whether or not it has a nucleus, the color of the cytoplasm, and then that distinguishing feature in the middle. So for size, it's 6 to 8 micrometers. No, there is not a nucleus. It is a salmon pink colored cytoplasm, and there is a central pallor that you can see under the microscope because it thins with the biconcave disc. All right,